Okay, hello. If I understand well, I'm the one to be criticized here. So please shoot. No, more seriously. When Jacques invited me, he asked like the question, what is the IPCC doing and what is missing? I guess I could answer a lot to both questions, and we could stop here or talk for the rest of the week. But I'll try to make it fit in the next 30 minutes or so. And first, to start with a caveat, I have not been involved as an author in last IPCC reports, so do not blame me for what is not good in there, and do not congratulate me for what is good in there. Though I've been involved as a reviewer for some of the chapters from the fifth assessment report and from the report now on the 1.5 degree target. And some of my colleagues have been authors, and I was also part of the French delegation at two IPCC General Assemblies, the one in 2009, where the outline of the fifth assessment report was negotiated and approved, and the one in 2014, where the summary for policymakers of Working Group 3 of IPCC fifth assessment report was negotiated and, should I say, disapproved? Well, approved. But there was a lot of negotiations, and the draft was changed quite a bit by the plenary, by the delegations of the countries that are members of the IPCC. So with that caveat, I will still try to present what the IPCC is doing, of course on energy, and give some ideas of what might be missing. So the IPCC, just to remind you, it's the intergovernment panel on climate change. It will turn 30 years old this year. It has 195 member states and 3 working groups. The working group 1 that assesses the physical science of climate change, working group 2 working on impacts, adaptation and vulnerability, and working group 3 on mitigation of climate change. And of course, we'll talk more of working group 3 here. It has a hybrid nature. It's a mix between scientific and intergovernmental work, because as you will see, the summary for policymakers, like the outline of the reports and the summary for policymakers, are negotiated by the delegation of the member states. And so the report itself is a mix between intergovernment and scientific nature, and the work is meant to be policy relevant and not policy prescriptive. So what the IPCC does, it provides policymakers with regular scientific assessments concerning of the state of knowledge on climate change, its implication and risks, as well as adaptation and mitigation. It does not conduct any research itself, but it reviews and assesses the existing literature on climate change. It identifies where there is agreement in the literature, where there are differences in opinion, and where future further research is needed. And to produce the report, it mobilizes hundreds of scientists, but that are not staff of the IPCC. They remain staff of their own organization, and there's only like a dozen of people who do work for the IPCC Secretariat. To give you an idea, the process to produce a report from the scoping to the publication of the report takes roughly 5 years. The scoping, it's a group of experts who propose an outline, a table of content for the report. Then at a General Assembly, there's the negotiation of that outline, and in the end, hopefully the approval of an outline. On the basis of this outline that gives the structure into chapters and subtopics to be addressed in the chapters, authors are nominated by member states and observer organization. The IPCC Bureau selects authors that produce a first draft that is reviewed by experts, and the experts can be anyone who registers to be an expert to review the report. On the basis of those reviews, the authors produce a second draft that is then again reviewed by experts and by governments, and then they produce a final draft and a summary for policymakers that is subject to government and expert review. And then the final draft of the summary for policymakers is negotiated. Line by word by word, it is discussed in a week-long General Assembly of the IPCC. And in the end, like every word is approved by whole member states. And it's then changed to some extent in that approval process. And in the end, the summary for policymaker is approved and the report is accepted. That it means it's endorsed by the countries, although it has not been negotiated as the summary for policymakers, and the report is published. So just to give you this idea of the process, and that's for the fifth assessment report for Working Group 3. Just to give you an idea, there's close to 10,000 reference of the literature that have been assessed in the report, and a total of almost 40,000 comments by experts and governments have been taken into account in the production of the report. So, and again, you probably all know that, but since it was created in 1988, the IPCC has produced 5 assessment reports, like the first in 1990, and like the last one, the 5th assessment report in 2013. In between, like the 2nd, 3rd, and 4th assessment report, this was taken from like a paper in Nature that sort of reviews it's 5 years old now, so it was reviewing the 25 years of IPCC work and noting that in the course we've been gaining confidence in the role of human activities in climate change, where, for example, like in 2001, in the third assessment report, it was stating that the observed warming is likely to have been due to the increase of greenhouse gases concentration due to human activities. It has become very likely in the 4th assessment report and extremely likely in the 5th assessment report. And this is, of course, more from Working Group 1. Also, I wanted to give you an idea of the role of scenarios, because I know that we'll be discussing a lot scenarios this week, and along the path IPCC has reviewed scenarios from like the first assessment report, where there was 4 emission scenarios and 2 economic growth scenarios, to last report where there's more than 1,000 scenarios that have been assessed. And also to note the importance of the energy community and the energy sector from the start, because a lot of the projects that have produced the scenarios come from projects that have been coordinated by the Energy Modeling Forum, that has in fact 20 years advance from the IPCC, because the Energy Modeling Forum was established in the early 70s. And so already the modeling tools and the scenarios from the energy community has been very influential in the IPCC, and has an important role in the scenario and models used. So now, where is energy in IPCC reports? Everywhere. Everywhere, simply because energy is the main sector, the main responsible for greenhouse gases emission, like CO2, this is like the sector decomposition. And if you look at direct emissions, energy is like the biggest part, but of course transport, buildings and industry is also a lot about energy, not energy supply but energy use, and a lot of the emissions here are combustion of fossil energy. So more than 70% of greenhouse gases emissions are actually CO2 from fossil energy use. And now I'll just go through the outlines of the various reports to give you an idea of where energy and how energy has been treated. This is the first assessment report, and you see it's quite short. It's only it's less than 300 pages. Now a report is more like 3,000 pages, and from the beginning, like one of the part was on energy. Because of course, energy is the main sector, the main issue for climate change. And also from the start, scenarios are important. Then in the second assessment report, if we look at the outline, it's more difficult to actually see energy. The word energy does not appear in the outline. But in all these chapters, the assessment of response option, estimating the cost of mitigating greenhouse gases, a review of mitigation cost studies. It was a lot about costs in that report, but behind those, it's a lot about energy. And if we look in more detail into the 7 chapter, you will see that in the mitigation option that are studied, almost all of them are about energy, and we could also probably add capture and disposal that we now call capture and storage, and also methane is partly an energy issue. If we look at the chapter 8 about the cost of mitigating greenhouse gases, again, we'll see that energy is here with the link between development, technical change, and mitigation cost, where behind there's some energy in the material content and energy content of development, the links between energy, transport, and urban planning. And in this report, what's I think interesting also to see is a lot of reflections about the methods, the models, and the scenarios with a lot of self-consciousness about the limits of the methods, and with here the limits, for example, or discussing the controversies, and again learning from the energy field. The third assessment report, in the outline, we do see energy coming here, the mitigation option in the energy sector, but other sectors, as I was telling you, building, transport, and industry are a lot about energy. And again, some discussions about scenarios and modeling approaches. Yeah, that's the fourth assessment report. The outline, we find back a chapter on energy, and also the other sectors that are very relevant to energy. And in the last chapters, the cross-sectoral perspective, the issue of sustainable development, and the question of policies and agreements, of course, deal as well about energy and other sectors as well. And now, if we come to the last report that I know a little better, we do find the same chapters, sectoral chapters on energy, transport, building, and industry, and with some chapters before with general issues about risk, ethical concepts, sustainable development and equity, and pathways. So a lot of the scenarios will be in that chapter, and many chapters in the end about policies and yeah, at different geographical scales. So we'll have a quick dive into the energy system chapter. Yeah, I'll skip to the key messages. These are how they are written in the chapter, but I'm making my own summary. What it says basically is energy is the main issue. It's only the main solution. The reduction of the carbon intensity of electricity production is a key solution together with the electrification of uses. Renewable energy technologies are part of the solution, but come with some challenges. Nuclear energy could also be part of the solution, but comes with some challenges. Carbon capture and storage could become part of the solution, but is still very uncertain. Replacing coal with gas in power generation can reduce emissions if fugitive emissions are low. Some policies have been implemented with some successes. More policies are needed. Governance and finance are key, and development needs shouldn't be forgotten. So this is my summary of the key messages of the energy system chapter from last IPCC report. So now, what is missing? I thought a good start was to start with the intuition that the keywords from this week workshop were an intuition that the organizers had about what could be missing. So I started with these. So some more macroeconomy keywords, macroeconomic stock flow, there is more models, and finance. Then more, some more technological issues for the energy technologies, the material constraint, the issue of grid stability and the issue of grid storage. The keyword of learning from the past, so the history of energy transition, because we want to do an energy transition, and there's been already energy transition in the past, so we should learn from that. And finally, more policy issues, decentralization, governance, commons, and inequalities. So let's see how it's present or not in the IPCC report. So for macroeconomy, in the whole 1,500 pages, there's once the word macroeconomy, which does tell something. But macroeconomic does appear quite often, mainly in the phrase macroeconomic cost and macroeconomic context. So where macroeconomy is present is to talk about mitigation costs and the effect of mitigation on GDP growth or issues like that. Then stock flow is not present at all in the report. But a number of the models that are used in the publication that are cited are actually stock flow consistent, and we could discuss that if you would want. Finance, it's treated very shortly in the chapter on energy, in not even a page. But there's a whole chapter 16, on finance issue. So Then we can discuss if it's treated well in that chapter, but it is given quite a lot of importance because it has a dedicated chapter. Now, the keywords on energy technology. Material has a short section in chapter 7. Grid stability is not used as a phrase, but the issue is treated in the section system balancing, flexible generation and loads, with like 42 references that are cited. And energy storage has 2 paragraphs. So I'll just show you quickly the paragraph. Just will not go through it, but just to give you an idea of like the importance that is given to materials in the whole IPCC report. And you see, for example, that the issue of scarce material for photovoltaic, the issue of life cycle impacts of renewable power, the issue of critical metals, rare earth elements for, I guess it's wind mainly, and the issue of recycling. So it's present, but not with a huge place. The issue of energy storage, same, it's 2 paragraphs, so 13 reference cited, with mainly a list of technologies that can store energy and short discussion about the potentials and limits of the different energy storage technologies. Now, if we come to learning from the past, well, there's nothing about, so yeah, we need you. So there's no history of energy transition references in the whole report. History is twice in the energy chapter, and once about the history of the EU ETS and once about the history of the energy security concept. So I guess we could learn from past energy transition more than we have so far. Now coming to like the more policy issues, decentralization is present both like in the energy chapter itself. It has 10 occurrences of the word, but it's also treated in the chapters human settlement, infrastructure and spatial planning, as well as in the chapter on national and subnational policies. So, well, again, we can discuss if it's well treated, but it is there. Governance is mentioned a little bit in the energy chapter, but is treated a lot in the chapters on policies, like the last 5 chapters. So again, I think governance is covered. The issues of commons and inequalities are not present in the energy chapter itself, but they are treated in the first chapters that are more general issues about risks, equity, sustainable development. But they are only, like commons is only in the phrase global commons. There's nothing about local commons. And also like an anecdote in the summary for policymakers, so of the working group 3, in the draft of the, you can look at the draft is publicly available, so you can check what are the difference between the draft and what was approved in the end. And in the draft, like climate change was flagged as a global commons problem, and there was like some sentences on this issue, and that couldn't make it to the approved SPM, and it was relegated to a simple footnote. So I think it tells something about how like some governments didn't want to see the word commons and global commons in the summary for policymakers. And inequalities, same, it's treated in the chapter 3 and 4, but it's quite absent from the policy. It's completely absent from the energy chapter and quite absent from the policy chapters. So I do think that it's an issue that the treatment of inequality and commons are separated from the chapters on policies. They're treated at the beginning in a sort of abstract and quite academic way, and then they're absent from the concrete discussion of policies. And I do think that here it tells something that is actually missing, having some concrete discussion about inequalities and local commons when evaluating the policies. So another way to discuss what is missing is to look at what the authors of Chapter 7 identified themselves as gaps in knowledge. And again, this is how it's written. So I tried again to have like my summary. So what is missing is good, reliable data and recent data for all countries for energy and emission statistics. There's a lot of uncertainty on carbon storage potential, uncertainties of leakage rates for methane, some risks associated with some technologies, nuclear, CCS, biomass, hydropower, are hard to quantify. The issue of the integration of high levels of renewable energy has received limited treatment. The impacts of climate change on renewable energy potential has also received limited treatment. Having a globally comprehensive assessment of all external costs of energy supply option is not fully available, and some more knowledge about the co-benefits, the trade or synergies, trade-offs, the effectiveness, cost efficiency of energy policy and their interactions with other types of policies are also identified as places where more research is needed, like from the authors of last chapter on energy. And then again, these are more my own thinking about some other gaps. Probably more life cycle assessment and material flow analysis would be useful. Having a more cross-sectoral view and systemic view, and not having just the sectoral chapters that make it difficult to have like a systems view. More discussion about the links between energy development, growth would also be useful, and more social science relevant to energy demand behaviors and to how policies can change the energy sector would be useful, because so far there's not so much social science involved. Well, economics is not really a social science. So, I mean, anyway, we could discuss that as well. So in the last 5 minutes, will the sex assessment report be better? We'll see. So just to give you an idea what to expect, so there are some special reports that are due one soon, like the report on the 1.5 scenario that has a very long title that shows you that it has been, like the title itself has been negotiated by the countries. It's now a special report. It's called the Special Report on the Impacts of Global Warming on 1.5 above pre-industrial levels and related global greenhouse gases emission pathways in the context of strengthening the global response to the threat of climate change, sustainable developments, and efforts to eradicate poverty. So that's the title of the special report that is now at the level of the second order draft that has been reviewed. So the authors are working to prepare the final draft. And the general report will be out. The work will start next year, and the reports will be out in the course of 2021 with working group through the second. And so for these, the scoping meeting already took place, and the negotiation approval of the outline already took place. So we already had the outline of working group 3 contribution, where we do find, again, a chapter on energy systems, and also the other sectors chapters, so urban system, building, transport, industry. On the things that are innovation, there's like one chapter on cross-sectoral perspective, so we can expect or hope for more systemic views in that chapter. There's also a chapter on demand, services, and social aspects of mitigation. So here we could expect to have more social scientists being involved, and knowledge from social science that is useful for energy transition issues. There's not anymore the first chapters that were more abstract on risk, sustainable development, and so we can hope that it's more into the other chapters and the policy chapters themselves. So those could be an improvement. And there's also an innovation, the last chapter about accelerating the transition is something new that was not present in previous reports. So if we go at chapter 6, I highlighted some of the elements that are to be treated in this chapter. So integration with other systems, decentralization system, practice and behavioral aspects, so here probably more social science, and the issue of interconnection, storage, infrastructure. And in the other outlines where energy is present, so in the chapter 5 of demand, there's the issue of sharing economy, collaborative consumption, and community energy. In buildings, there's the issue of energy poverty to be treated, and in transport, the systemic interaction, in particular with the energy sector, and life cycle assessment and material flow analysis are to be treated. So this is what to expect from the 5th assessment report. Some concluding remark, maybe some remaining gaps. I would say mainly issues of communication. I don't know if you've read IPCC reports. It's quite hard to read. And what they've tried to communicate better is to have frequently asked questions. These are the 3 frequently asked questions from the 5th assessment report chapter on energy systems. I think it's still quite difficult. I mean, not probably, well, it depends who you're aiming like the communication for, but these could probably be improved. And also the SPM, which is like the thing that is probably the most read, the summary for policymakers, and which is like the thing that is translated to other non-UN languages, is probably limited for communication, and also some elements do not make it to the SPM because it's negotiated by the countries. And in particular for working group 3, a lot of the some things do not make it to the SPM. For example, for last assessment report, all information about the regional disaggregation of past emission couldn't be included in the summary for policymakers because it was too touchy for some delegation, and also all the elements about policy evaluation was cut off from the SPM. And the more we go into the transition, the more we will need some evaluation of policies that are put in place and some communication of that. And if we use the SPM, it will not be in the SPM. So probably there's a lot to do about communicating the results. So I'm done with my presentation. Thank you for your attention and for your questions.
So I will accept only 4 questions. Sorry. And yeah, 1, 2, 3, 4. Sorry if I didn't see something.
I'm Sébastien Balibar from Paris, the École Normale Supérieure. I'm a physicist. As a physicist, I like numbers. And I would like your opinion on the very strong reductions in energy consumption, which one finds in various scenarios. One example is the French law. The French law assumes that it's possible to reduce the energy consumption by 50% in 2050, but that's a total number, or if you convert into per person, because the population increases slowly, it means dividing the energy consumption by a factor 3 per person in 2050. I was a bit surprised, so I looked at the situation in California. California is even worse. That is the scenario that is proposed by Mr. Jerry Brown and his government predicts that the consumption of energy in California should be reduced by 64 to 69% by 2050. So even if it's possible to save energy in transportation and in buildings, as was very well said by Yves Bréchet, do you think that it's really rational to suppose that one can reduce the energy consumption by that much in 2050? Sorry, I was a bit long, but...
The question that... Oh, I'm sorry. Susan Krumdijk, mechanical engineering professor from New Zealand. The question you were addressing is, should there be an energy group in the whole program of IPCC? That's what we're asking. The premise of the IPCC, the problem of energy is, if we're going to meet the targets by 2040, that problem is a problem of industry and engineering. And it's a problem of rules and regulations, not policy. So yes, we need a new thing, and it needs to be set up not in the same framework as here, where it's about science and that, because if we are going to actually do something, we have to count for inertias, and we have to look at demand, and we have to do things right now. And that's really different from studying things some more. Okay, so that's my comment.
Hi, I'm Pierre-Olivier Lemire from Université du Québec à Trois-Rivières. I'm a PhD student in agriculture engineering. My question is, what is exactly the controversy on the top-down and bottom-up modelization, and how the IPCC managed this controversy? Thanks.
Gregor Erbach from the European Parliament's Research Center. First of all, one question, can you tell us which governments were opposed to having the commons in the SPM? And then the real question is, some of the issues that are missing from the IPCC reports are addressed by the International Energy Agency and the International Renewable Energy Agency, and also to some extent by the UNEP International Resource Panel. And how do you see the relation between the IPCC and those organizations?
Well, I mean, not all of your questions were directly linked to my presentation, but I'll still try to take them. So maybe I'll start in reverse order. So yes, other institutions are looking at issues of energy, and like some international or some national institutions are looking at energy making scenarios, and the IEA is one, but in France, other institutions as well, like ADEME, or are doing scenarios. So what is supposed to be the link? I don't really have an opinion on that. I mean, both organizations and people developing scenarios do talk to each other and criticize a lot what the others are doing, and try to also be a bit more constructive than that, and specialize on where they have more strength. The IEA, for example, is not a global coverage. It's a rich country organization, so it cannot treat the issues in the same way that an international organization would. So, yeah, I guess there are some limits as well there. Also, the IPCC is trying more and more to review and assess and incorporate not only peer-reviewed literature, but as well reports from other sources that are not formally peer-reviewed and can draw from the IEA or other national studies. So I think that's an improvement. Then I hope it answers a little bit your question. Then on the controversy about bottom-up and top-down modeling approaches, this is quite technical, and I didn't touch upon that. But the idea is that there used to be two different kinds of models, like the bottom-up models that are partial equilibrium model looking at only the energy system representation with a lot of detail on the technologies, but nothing or very limited representation of the macroeconomy, and not taking into account, for example, the retraction of demand, like what happens in the energy system and how that interacts with demand trends, or how there might be investment constraints in the system, or other interactions between energy system and more generally the economy. So that's the bottom-up part. And the top-down part are more economic models, often general equilibrium model with production function that are with constant elasticity of supply, that do not represent very finely the technical realities of the systems that they are, of the sectors that they're representing, and not able to grasp the technology, the physical limits, because these elasticities of substitution, the constant elasticities of substitution, they are calibrated on past data, but they have a limited validity, and we know that when looking at transition, we'll probably go out of the space of validity of those elasticities. So, but those models have the strength to actually represent all sectors and the interaction between sectors. So the two models have different, like the weaknesses of the strength of the other type of model. So now more and more the models are hybrid, to try to have, like, to combine both technological detail and macroeconomic completeness. And so they're slowly converging. But still, the different models used are still different, and it's good to have a diversity of models. And then the question is, which tool is good for which question? And the idea is to look at, do you have the right tool to answer the question you're looking? So, but we can talk about that more if you would want. Then on the issue of more a sort of a task force to actually implement the transition and not just study the transition. Yes, of course, we need that. It's different from the IPCC, for sure. You will need on board the industry, you will need on board the engineers, and you will need on board some economists, some social scientists, some people from the civil society, some etc., etc. And for sure we do need that, and it's different. Then one slight thing, I don't think that regulations are different from policies. It's one type of policy. You can have policies that are regulations. You can have policies that are carbon taxes or things like that. And what we do study in the IPCC is what are the effectiveness of different types. Like, are regulations better than carbon taxes or than quota systems, and what are the interactions of all of these together? So there's also some knowledge needed, and what are the impacts of different types of policies, including regulations, on emission reduction, but also on distributional issues and other things like that. So yeah, I think we also need to study regulations and what works and what doesn't. But I agree, we need that task force to do things, and it's different for sure. But then it also is probably something more national, and then I'm not fully sure we need to coordinate internationally that task force so much. We would need some exchanges, but yeah. And then on the issue of energy demand reduction, this is quite far from what I presented, to be honest. And I'm more familiar with global scenarios than with French scenarios. What I can say on French scenarios, and what is now on the table and being discussed as like scenarios to go to carbon neutrality in 2050, is we don't fully know how to do that, and we're like, everyone is still scratching his head what exactly neutrality means, and how you really go to zero net emissions in such a short time, because 2050 is tomorrow, with the inertia in the system that we have. So then what role energy efficiency and demand reduction has to play in that kind of scenario? It has to play a role, for sure. Probably dividing by 2 demand is quite too ambitious.
This is what the law is saying.
Yeah, but okay. But what happens if we don't do it? I mean, what is really, the law is one thing, and stating something for 2050 is quite easy. Then the question is, what do we do now? And if we really think we want that, then we need massive retrofit of buildings that is, for example, that is not happening at the rate that we need. So, yeah, game over.